guys, and welcome back to another session of Azure. And today we have with us Rajesh Thakur, who is in application strategy. Let me tell you about his application. He's a data engineer compliance, also a certified trainer. He's also a certified and he's also an Microsoft Azure Dev Lead. So he's going to be one of the best personalities speakers and today he's going to tell us about Azure ML. This is basically for our AI and I hope it's going to be really beneficial for you all and you must have enjoyed this day one. If you have any kind of queries or anything, you can click on the chat section up and I will surely help you. Over to you, sir.
Great, I think we can share the screen now. Cool.
Yes, sir. Screen is visible.
Great. So we'll continue with where we left off yesterday. So we did jump to the part where we started designing with machine learning designer. So we'll get back to that space a little bit later. So we'll try to complete this, to understand the basics of the classification. We did start it earlier for few of the folks who might have joined in late or who have joined new today. So you might be a little bit lagging on that space, but we'll try to catch up on those aspects as well. So this is what we saw as today to find out our regression that we have completed it almost the entire part. But for this one, we haven't touched a lot. So we'll try to kind of touch it entire thing, how it is happening, why it is happening, and what are the things that you might be mindful of. So as you see, the same graph, we did have a graph earlier with just X and Y. We do also have the same X and Y. Apart from what was different from the regression part is we do have a limitation, right? So for a regression model, the stock market, as we have discussed yesterday, it can go up to any range. It can go up to hundreds, it can go up to thousand, millions, billions, and so on. So, but for the classification problem, we do have a fixed space of values that you can get. So you know that this is the result that you can get. So you can either crack the exam or you can fail. So those are the only two possibilities or the exact possibilities. It is 0 or 1. So let's consider 0 as a fail and 1 as getting a pass mark or getting the desired mark 700 plus. So what happens here is we do have a fixed space, as I said, 0 to 1, or the values can be in between. Let's say if your prediction is perfect to this range, or your prediction is perfect to this level. So that is something that we would not talk about. But again, this is something that you should understand of why this graph is of this sort. We did see the regression part yesterday, which we did understand it pretty well. But classification is not pretty much self-explanatory, right? What happens here is you do have a fixed value, but that can vary depending on what kind of accuracy that it can give. Right? What is the percentage? So let's say if I say that this guy would clear the exam after attending all these 4 days of workshop boot camp and the final day of quiz. So I would say that as a percentage, so I have like 70 percentage or 80 percentage faith in this guy, or I do have the confidence in this guy that he or she would crack the exam. So I would say the percentage along with what is the classification that I've made. Like this guy would pass with 90 percentage. So I say 90 percentage, or she would fail with this percentage. So this is the probability that we have. So probability never crosses 1. So that is why you see the range. So whatever the value it is, whatever the range that you can pick, it would be inside zeros and ones. So whatever the range that you pick, whatever the range that you want to decide, it would be in between these two. So that said, do have a curve. We did see the last time we did have a straight line. Obviously, we try to draw a straight line to get the x and y coordinates. So let's say in any point in time, you just need to tell the weather. What is the weather would look like? If it is 100 degrees or 95 or 80, we can tell at least to some extent based on the line that we draw yesterday, like the line through all the points. The points are plotted with the historical data. So that is one thing that we saw yesterday, which is pretty similar to what we are seeing now. Apart from the case where we do have various factors, so the x can be multiple or it can be one. So it kind of depends on what is the problem that you are picking or what is the thing that you are picking. So it is either 50 and above, as let's say it is 0 since it is like P1. So that you can definitely say what exactly is happening. So now the data suggests how you plot the data is not really important. So how much percentage is it is important. So probability of 0 is 0.8. So obviously you know that 80 percentage of the time that this or this model can tell that he or she would fail with 80 percentage accuracy. So that is how you have to look at all the data that we have. So it is pretty similar. Plotting, you don't have to really look at the plotting. It would be a little bit weird to see the plots as we see it. So on the regression, regression is pretty similar, where you can just have x and y coordinates. You can even draw on the actual graph, or you can put it in any Excel or wherever you can have a graph axis. You can draw that, but this case it is really hard. But again, if it is closer, as we see 60 and no, 60 percentage, and what is the remaining is 40. So for this space, how you see is that could be a possibility. Since it is 60, it is 50 plus, so we consider that as pass. But again, there could be a space where you can tell that it could be 50 or 51 or 50.5. So it could be really close, really tight, that you can't definitely predict. Or this is the exact thing that this guy is going to get. Apart from if you have 90 percentage, it is more than clear that it is going to be he or she going to be getting the certification. So that is one thing that you have to understand. And the second part of having this is how what is the so we know the actual one. So we know that this is something that they can get. So let's say someone has prepared or someone has prepared for 2 months. So we know the data. So like 2 months of preparation, he or she can obviously crack it. But without preparation, or without the level of preparation, without the uh, effort that they have to put in, it is really hard. So let's see a random chart. So we call it as matrix, right, where you have few of the data that you want to highlight. So one is so we'll have it as pass. So the model is predicting, and this is the actual one. So the actual, we have the data. So this is the data that we have. We know that this guy is gonna pass with some percentage, right? And this is some percentage that we know already. This data is already available. This box that you see is already available with us. So the first part you see is one-on-one. So one-on-one tells that the actual data is one, and how much actual data that model can give us. So this would be useful when we see the scores of how the model is performing. We obviously compare classifications with the accuracy. Most probably we would compare how accurate this is, or how much recall that is. So that we will discuss later. But to just have a basic understanding of how we would compare models. So this is how we compare. What is the accuracy? So let's say if my model is 90% accurate, it could if you give 100 data, it is going to give you 90% the right output. So that is how we have to look at it. And let's say we have zeros, so we would have this matrix, right, which is true positives. We might even call it in that way if you want to. It is a technical term. So true positives, or truth, is the part where that is the ground truth, we would say. Positive is that aligns with that, right? So the model says he or she would pass, and we also know that he or she would pass, so that syncs up. The sync is there. So how much I've synced? So 126. So 126, if you add all these numbers, you should obviously get the how much data that you have put into validation. So I didn't talk about how we split it. So let's say you have 1,000 records. So 1,000 records is 1,000 rows of data in a CSV or an Excel sheet. So let's say we have that, right? So 1,000 record. So so why do you split it in the first place? So why can't you, someone can say that, hey Sandy, why can't we put the entire stuff in training? Why do we need a validation? Right. So what happens with that space is, the model tries to you know uh, fit it very accurately. There is a problem when you fit the entire data very accurately, and all the outputs or all the validations, right? So if you know the entire stuff, why do you want to use the same data? You just need to give a different data to check. So for validating that, if the model can give me back to some extent, so that is why we split the data. So in easier terms to put it, let's say you have, why do you need a book bank and a question paper? So question paper has the entire, or the book bank has almost all the questions, right? The question paper could have few of the questions which may not be, or which you may not have learned. So that is the validation data. The validation data is the actual question paper that you're going to get, right? You may not know how you will score in that, but the question bank, whatever you give it in the question bank, you can tell it almost 100 percentage that this is the answer for it, or this is something that you can definitely tell out. So that is this box. You kind of split. So the split can be of any percentage, but obviously we, as a as a developer or as a data scientist, we split it 70/30, or call it as 70 percentage for the training part and 30 percentage for the validation part. So that is how we have it for the first page, but you can definitely change it and play around. You can have 80 percentage for training. That it totally depends on how the data and how well the model performs. So let's say if the model is performing bad or worse, then you can just increase or decrease. So that totally depends on what you want to do. It can vary, or you can definitely play around. So it is not like a bulletproof thing that this is the something that you have to definitely follow. We don't have any rules of that sort. You can definitely play around. So hope the training and why do we split is clear. So we'll go back again to the matrix. So you can call it as a confusion matrix. So that is the exact term for it, but matrix would be fine for just to understand. Since it is a 2 cross 2 matrix, so many people know how what is a matrix. So it has rows and columns. So it would be easy. But the technical term, or the term that we use, is a confusion matrix. So as I said, one on one is right on point. The model has predicted that this guy or this girl would clear the exam. But for this one, right, for the 21s, the model is saying that they would pass, but we know that from the validation data that he or she would fail. So this is you call this part as something that a model can improve on, or you can also call false positive. So we know that this is false in the sense it is not going to happen, or you can say zero, right? But the model is saying that this is a pass, or it is positive. It is positive in the sense it is what it is, or it is one, and they would clear the exam. So that is how you have to understand this one. In the same way, when you come to the second row, what we see here is we say that all these 126 people are gonna fail, right? All these people are gonna fail. We know that this is gonna happen, but uh, the model tells us something different. So the model tells us 7 people among that have some kind of a probability that they might clear the exam. So that is how you say that as a different term, right? So how you call it as a the model tells us something, but we haven't validated that yet. If you don't have the validation table, you can't say that model has given wrong, since you don't have the actual data. Let's say you give a random number. Let's say someone has prepared for 10 days, and 10 days there could be a possibility that he or she would have prior knowledge of Azure. They can crack the exam, right? So the prior knowledge of Azure can help us. They have working experience that can help us, that can help them. So that is something that you should be mindful of. And so that is where the 7 people come in. So we call it as false positives. And for the 119, which is the truth, or which is exactly the what we need, or that is the right way. 0 on 0 is model is also, predicting that this guy would fail, and we also know the real truth that this is gonna fail, he or she gonna fail. So that is something that is called true negatives. So truth is the first page is the truth. So truth is 0, and it is negative, and negative is the part where we tell it is 0 or 1. So you can correlate on truth is a ground truth, the sense that is what it is, that is what we need, actual need. Negative is what the model gives out. It can be 0 or 1. So that is how you can form the matrix. It is not pretty complicated. It is pretty simple. The first part is where it is truth is the actual truth. So for 126, that is the actual truth, and 126 for the one on one is 126. When you go to the second phase, all the 21s, we know that these are false. This won't work out. uh, these 21 are absolutely failed, and we also know that that is negative part. So negative comes from the model space. Model tells us that these people are going to fail, but we know that these people might, clear or may not. So, but the model gives us that it has given that, this guy is going to, clear the exam. So it is 147 people would clear the exam, the model is telling us, but we know that only 126 out of them have actually cleared the exam. So let's consider this table as already the data that we have, the data that is, so we have validated the data. Let's consider that. So this data has been validated. So these are the, let's say, consider them as a days, how many days they have prepared for months. So we do have 1, 2, 3, and 4 months, how many days they have prepared, and zeros and ones. So this is a different data set, but again we'll just consider for the easiness of the understanding, for you guys to understand it better. So zeros again, it is fail, and one is, you're cracking the exam. So the model tells us these people are gonna, clear the exam, and this space, the model tells us is 0. So we know that actual truth. So this is the actual part, or actual uh, truth that we have from the table. So this has been validated. So validated is something you can do it manually, or that. Let's consider that you have validated in some space, which we don't know, but this is validated. Just consider that it is validated. So with that said, 21 or false, we know that first part, as I said, it is the actual truth that is false, and the model is also telling us that this is something, it is going to give negative, since we are also telling it that as a false. So that is something that you can work around. You just need to have a bit of understanding to know why it is called, confusion matrix is something I haven't really discussed, but again, as I get explained a lot, with this part, it is really for you guys to experiment and understand, rather than someone trying to explain each and every part of it. So if it got somewhat clearer, maybe not, maybe yes, but just try to understand. Or if you are take a real time example, or take a different example. This one was a different example, I guess. So it was, I think it is diagnosing with some medical records, I guess. But to for the easier understanding, I took another example out of the same data set. But you can understand this when you, do the code, when you implement stuff, and you can, construct the same confusion matrix, so that you can understand better. So the third part, we have seen two stuff. So one is the regression part, and one is the classification stuff. So this is the clustering phase. So this is the problem that we saw earlier. So earlier we have seen that you can classify it with whatever the knowledge base that we have from the yesterday's session. You can tell that these two flowers are the same. You know that by the knowledge that you have, or the machine learning model can tell that this is something that is the same. So what you do in clustering, as the name suggests, you kind of group things. So whatever similar, similarities that we have, whatever closeness to each other, it can be anything. So for the first two models of the ML, we know that this is the space that we will get, or this is the number that we would get. For classification, we don't know the exact number, what is going to be. For the first part, we may not know. For the regression, how much in the future you want to predict, or how much backtracing is, I don't think that works. But how much in the future is also not clear, since you can go to any number per se. But again, for clustering, you don't have an exact number. So let's say you give 1,000 data, 1,000 can be unique, or only 500 can be unique, or only 100 can be unique. You never know how it is done, uh, which part of it uses futures, by the way, but you never know the exact number. But you can definitely tell the model, if you have used couple of classic clustering models, you know that you can name it as, I just need three clustering, or three clusters. So it would try to cluster the entire data set that you have into three stuff, right? So that you can definitely do, or you can give that the freedom that it can group things in any form. So if you have used SQL group by, it is pretty similar to that. But group by could be, it would be just group by the entire stuff. Let's say you have similar records, it would just group by stuff and it'll give you the count. But for this space, you can definitely stop the model, say that, hey, I just need three. You can just use it for classification, but I haven't done that earlier. But you can definitely try out different things so that you will understand stuff better. So you have some similarities that you want to kind of see, how this is related to this, or why this is related to this, and why not these two are related, and why these two are related. So that is something that you should understand. This is done by the feature that we have, how much number of features that you give into, or how much number of inputs that you give. So the more data that you have, the better the model is, the better you can train stuff. So this is something that you should understand on how and why it is the cluster. And there are a few technical terms that I don't want to go into. They call it as centroids, and few math stuff is there. But for basic understanding, how things roll out, this is something that you should understand. So what is the metrics, or what is the relation that it has to have that? This is the space that so what happens in this space is, you have a point, let's say if that is closer, so everything comes to the graph part. We don't have any kind of visual, or we do have neural networks for doing it. It also does something different. It's similar but in a different way. We'll talk about that in the next day, maybe. But for this one, we know that this is the data and this is where the plot is going to go. So the graph, we know that how far from this centroid, or how far from the point something goes. So we know from that data that this is going to be, or this pretty much the basic stuff. You can try out with k-means clustering, which is almost pretty old, or it is pretty much the one that people use. You can use scikit-learn, you can import it from there. But that is something you should be trying out, just not looking at it. It could be confusing. It has been confusing for me a lot when I just started learning. I didn't have anyone to teach all these things. But again, you can definitely try out so that you could understand it more better. So it's just not that in just 1 hour you can understand the entire ML stuff. If it is that case, right? So everybody would tell that in a week or a month they would learn the entire tech stack that we have right now in the world. So this, you can try out various things. What could be the point of reference, and what is this centroid point doing? How this is not related to this? Why this could be related to this? Why can't this be related to this point? So all these things, when you plot it out, when you have direct metrics, or when you have the exact metrics, you can. We do have like I think it is the shape or the size of the flower. So, or it could be something different. So, but again, I just want to know that this is something, some metrics that we have, some X, let's say, uh, or some Y maybe, and you just need to plot it to say that this is something, and this is the petal shape, or this for a flower. It mostly depends on the petal size, or the petal count, all these factors. So you have a flower, we do have the metrics, we know that we can count it. As I said, we do have the knowledge base of how many flowers exist. So we will use that to make sure that we kind of club it together. So the final piece, where you kind of club things closer to what the exact point is. You could have the these points, as I said, just three. If you just tell that I just need three group buys, or three in the group buy, it can be two parts. So we just have six datas. Let's say we have only six records. It is pretty difficult to understand with just six. If you have more records, and if you have a better example that you might go well with, then it could be really easy. You can just consider this as a starting or a base point to understand stuff, but you can relate to whatever you like. Maybe I just don't want to get into sports again, but specifically football. But again, try to understand in your own way. This is the basic idea of how things look, but you can understand it in your own sense of what you can relate to in real life. So that kind of really helps you to understand it better. And implementing stuff, again, it is really important to just code it out. You don't have to really code it out, just copy and paste stuff. You can start learning that how things work. So as we have started earlier, the I have shown the studio part. We did see a couple of blocks of content. So there was like a flow chart. Maybe you can consider that, but I would call it as pipeline. So that is the word for it. So, what happens in Azure is you definitely need a subscription to do whatever or anything that you want in Azure. For everything that you want to do in Azure, you definitely need some sort of subscription. So, once you have that subscription for Azure Machine Learning, in particular, you also need a compute service to kind of do the stuff. So I'll show you how this compute service is pinned up. I started it. Yesterday I stopped it, and I started just now. So it kind of takes some time to spin up things. So I'll show you all these things. You can just digest these how things look. Compute is where the process happens. So let's say you can consider that as a server, and data is a database, and models is once the compute is done, you train a model. The model is ready for prediction. So experiments is where you can run the entire compute. Let's say I want to train a model in different areas. So let's say you have three clustering that we have talked about earlier. I want different number of clusters, and I want to see how well that is performing. Let's say you have a classifier. I want different types of classifier. We do have n number of algorithms to do that. Random forest is one. You can also implement neural networks. So all these part or all these machine learning models in neural networks, you could literally go to any level. We do have already pre-trained models available. You can definitely use them. I'll also talk about what are the models that we have and what exactly you can use them for in the later part. So this how it looks like. I'll just show you the live portal. I don't want to do that on the slides, but I can just have a look at it. This how it looks, the actual stuff. So what you do, you have a data, you have it somewhere. You might be having it in an Excel sheet, you might be having it in a database, wherever you have it. The center part is where we focus on. The center part is what machine learning does. But for this part, you don't have to do anything. You don't have to do any sort of pre-processing, or if you want to do, you can do it. But just give the data. Just tell that this is something that I want, and as it suggests, it would find the best model. So it won't be perfect, as I said. You don't have to uh, definitely say that automated machine learning, whatever Azure provides, is the best model that is available for the given data space. No, it is not the case. It has not just me. I'm not saying it just because I want to say it, but the experts, whatever you see in the conferences, they have said that this is something that you can use as a baseline, of where you want to progress. So like, there are different models. As I said, you have a baseline. On top of the baseline, you can build whatever you want, or you can just go in that space. So we'll also talk about parameter tuning, hyperparameter tuning, all these stuff. But don't want to get too technical, but we'll just jump into the live demo right away. So this is something that you will see. So I don't want to take much of the time. So this is a pipeline that you say, as I said, you can consider as a flowchart pipeline, whatever you call it as. Definitely that works. So yeah, let me switch. I hope you guys can see. Cool. So this is something that I started spinning. I think it is running. Okay. So I hope. Okay, this thing doesn't. So I think the light one would be more easier for you guys to see. So I did create something yesterday that I have shown. So this is what you see on the portal part. Whatever you have to see. Um, so for the labs part, right? So I'll tell you place where you can go ahead and do it. I'll put it in the chat later. Right. So there is some way that you can do get free 4 hours of credits inside Azure. I'll tell you how exactly to do it. So this is what we saw yesterday. So I'll create a new stuff. So just go to new wherever you click. What I want to do, what we showed is automated ML, which we have seen. So notebooks or where you can, as someone is suggesting, Kaggle for data set, you can use any data set for any sort. So automated ML notebook is pretty much similar to the Kaggle notebooks or Jupyter notebooks that you see out there. And the designer is where it is a, as it suggests, drag and drop. You don't have to code, but you can do if you want to code really. You don't want to implement something that you really wanted. You do have a script that you can definitely ingest right away inside the code, inside the you know this space. You can just edit, start editing. I think we do have the code. So what it asked me is for the compute part. So what is the compute that I need? So I have created another one which is already existing just for a demo. You need what is the compute that you want to go. So compute instance is the base one, which is really free or it is low cost stuff. Compute cluster is if you want, if there are multiple people in the team. Let's say there are 5 people and they want to train different models, then you can get the compute cluster and then you can start working. And the attached compute is dedicated to you. It is some you can use definitely for sure. So it kind of cost me. It is not free. Of course, you can see 0.07 dollars per hour. So you can start it and stop it. So I did stop it yesterday. I just started it right now. So you can definitely see. I think it would take some time to give you the entire space. Um, Not sure how much time it would take, but we'll just see how things are and what kind of discussion that we would have. So I'll just see how the data is. So we do have 32K records and we have 15 columns. So whatever the columns that we have, what we have to predict is the income. So it is a classification part. So it is a binary classification to be specific. So you have zeros or ones. So I think we are using like 50K or below 50K. So that is what we are predicting. So it kind of gives you a visual look of how the data is. So whatever you see over here is pretty easy to look at. So you can see their name, what is their age, what kind of age that they are in, what are the different categories of age that people are in. So what is the mean, median, what is the min max value of it, what is the standard deviation, how much unique value. So all these matter when you do kind of some sort of pre-processing on the data. So let's say I don't need what data can we remove. So we would use a correlation matrix, which kind of tells that, say, let's say, if this guy is not a bachelor, or if he's a bachelor, he would have less experience and he wouldn't have more salary. So that is something that might correlate or might not. It totally depends on the data if it is making sense, and you can also have some kind of data, right? So if the age is higher, they would obviously have more income. So that is something that we know as a human being. As again, we know that if someone is 40 plus, they would obviously earn more than someone is earning at 23 or 30 or somewhere around that. So that is obvious. But in the machine learning space, you just need to consider how the data is. So your relevancy is more dependent on uh, the data rather than your assumption. So it can work sometimes, but the data speaks for itself. If, let's say, if that correlation doesn't exist, let's say more people in their 30s and 20s or earning higher, if the data says that, it is a common conception that people who are aged more earn a lot than the person who is lesser age. But if the data that you have, whatever data, so this is the data space that we have. So 32K is something that we have. So if this space tells us something different, or if it doesn't correlate with whatever the real world tells you, whatever the common sense that you guys have to kind of figure out if that is the case, right? If that says that that is wrong, then that is wrong. Since you have the data that you have to feed in, you have to train stuff, right? And again, this is something you can definitely say how the private people or more in this part. And you can also print something which says that whatever the income that these guys have, how much percentage of private employees, their if their income is higher, greater or not. So that is something that you can relate to. You can definitely try out the correlation that I said. That is the technical term again, but the basic understanding would be uh, when if the person is higher age, then if they are older, then obviously they would have higher income, or they would definitely have above 50K. So that is a general assumption. But if the data says that if it is not right, if you remove the data and you can retrain the model, you can just play around with this one so that you could understand if it is really the case or if it is not. So you can, as I said, use the compute cluster if you want to. If there are more people, or if you want to yourself deploy 5 experiments. So we do have one experiment running in our case, right? So we do have one experiment that is currently running, but you can definitely run various experiments on with various parameters and various data sets to kind of give out a model which can tell that with various results or various accuracies that you can use. So I think the data set is pretty much. I don't see it as clean. You just need to convert these male and females to zeros and ones, or these values to something that they can relate to. So all these pre-processing part has to be done before you give it to a model. So let's see what these guys have done. So what kind of stuff? Okay, I don't see anything. So usually what you see is how it is doing it, so at which step it is. So we do have the data, so it is trying to split it. Okay, it is splitting into half. First data set, whatever you want to read, you can definitely go through the entire stuff. So the preview over here, whatever preview is, it is a general preview. So there could be questions on this as well. What if it is in general preview, who has the access to it. So that is something that you can obviously expect, and most of the cases, those questions would come up. So this is something I can you can set it. Not sure why you are not able to. Okay, anyway, so here what we do is we end up there setting that this is the thing that we want to predict. So the income is something they want to see if they get, let's say I give a random person random name or a random number, and it has to tell that. So we ought to also have the features. So what are the features that you want to use. So again it kind of continues along. So this model could be anything. You can have different. You can use your custom scripts if you have any. You want to import. Let's say I did have a couple of custom scripts. I'm not sure if I could find that, but you can definitely use execute custom scripts in alongside this part. So if you want to, let's say, do some kind of pre-processing or some kind of part that is only that can only done by a code, it can be Python or R. Then you have to definitely use that. You can't have a different part of doing stuff where you definitely can't use a drag and drop tool in this case, or you can't have any pre-trained or modeling that is already there, or all these stuff whatever you see, all these have pre-trained or I would say as a structure to it, or some code is executing at the back end. We know that whatever transformation tool that you pick, adding columns, converting, all these stuff would obviously turn into a code and run. But these are I would say code snippets uh, that you can drag and drop wherever you want. So split the data, put it somewhere, features that you want, and then you select the columns that you want to transform. So this is, I think, where they would start doing this part where they would start making the columns into values. What you see in the first page is the male, female, all these variables. So we don't use the variables to train a machine learning model. We obviously need numerical data. So at the end of the day, whatever you feed into this model, right, where it is in the training phase. So train model is where you just need two stuff. So one is the model that you want to use, so it is a standalone. So you can just put it aside. So it is a standalone, and what you need is a data part. So the data comes from whatever the features that you want to do. Then there are three phases, I would call three or five phases people use, but this is something that you can definitely try out. And it is not just only these phases. So one is the pre-processing phase that we are doing. So we are filtering out data, what we want, just to five features. You can try out with a number of features. We do have, I did 15, I guess. So apart from one is left out of the target, so we'll have 14. So you can try out with all the 14. You can try out with 10. You can try out with 7. So it totally depends on how you do it. It is not fixed number to kind of do things. You can definitely try out with any number that you want. The second phase is training the stuff. So where you feed in the data, you tell that this is something. If this is present, this is the output you have to show. So it is kind of teaching a kid to kind of construct something, or it is kind of teaching someone maybe to kind of put them into a habit. So pretty much it kind of does the same. So if the data is something of this sort, so if the person is having age 35, and he's in a private job, and his experience is maybe higher, or working experience I would say, and he has a MTech degree. Okay, and this is the output that you have to show, or this is something that you have to memorize. And there could be a second data set where it says 20 years age, 20 years old, and he is a BE or BTech graduate, and he also has some kind of relevant skill set, but he lacks the experience that a person with 40 years has. So with that space, you tell the model that he would earn less than 50K. So that is how the model happens in the first place, how exactly it is getting trained. So you could see this exact thing with decision tree. If it is really perfect, it is a tree where it is if else, right? Whatever you tell, that is a if else with priority. So what priority that the second comparison should happen. So let's say the first comparison is with the degree. So let's say if the person is having MTech degree, then obviously he would land up. Let's say you have right and left. So if this guy has a degree, then he would go to the left side, and we would compare it further with if he has relevant experience or relevant skill. So once that is set, you put it aside. If he's married, or you can have different features that you can use, then you can tell that finally that this guy would be earning 50 plus 50K plus. So that is something you can definitely see in a decision tree. So you know that this is the metrics that the model is using. You can just print out the entire tree if you want. It will be a huge tree, maybe 100 rows or 100 levels, if you want to call it as. So that you can definitely do. For others, for neural network, as I said earlier, you can definitely print out the weights and biases, but you wouldn't know how it got set. So that is something, it is a mystery. You can't figure out exactly. You can do it with some kind of deeper understanding on um, the exact formula that it is using. It is obviously using a formula, we know that. It is using some sort of formula to figure out the weights for the given amount of data. We can definitely do that, but it is a bit difficult. So it's still for entry level people, for like me, or for people who are just starting out, it could be a little bit difficult to understand how exactly things are happening or how exactly things are moving. So I think it is taking some time. It would obviously it is a the cluster size is pretty less. I'm not sure on the size. um, I think it is the least I could get. So it has just one course and 2.5 gig of RAM. So it is the least amount that I could get. So it would take definitely some time to complete this. But again, this is how I think I can show you another one. I do have another one which um, I don't know to save anything. So this is something it is already done. So we can definitely look at the entire stuff, whatever we have. Again, we'll just look at the data set. I think we are training another one. I think this one is already done. So you would also have some questions on how do you log things, as you can see here, driver logs. So this is something, if it is going to, I think it would be asked in DP in 100, but it can, a few questions can come on how do you log things. But I don't think that is relevant to what we do now, since we don't have like a script. So only if you have a script, you can log things for the splitting and other stuff. We don't have actually a log that you can track back and say that this is something that you can do, or this is something that it has already done. So this also we see 50 percentage you can do it with anything. Another part you have to do is you have to randomize stuff. So pre-processing is a huge part of building a model. Is like it is easier than doing the pre-processing, since you know that this is the model that you want to go. So that is also difficult, but I wouldn't say that it is as difficult if you have a good clean uh, workable data. If you can work on the data more, then you come for modeling and training, that would be more easier, or the model would be more accurate, I would say, than having to have some random stuff, just throw different models, keep training stuff. That would be really hard for you guys to see. So I would see that to kind of get along, try different things, but just make sure you clean the data. Processing is second part. You don't have to do anything, the machine does it for you. But the pre-processing, that nobody has figured out exact way, or the brute force solution, or there could be some solution which is brute force. You could say that if it is male female, you can just swap it to zeros and ones, and if there are other values, you can also do it with point one and all these values. But there isn't a exact way of doing it. It is totally depending upon the person or the engineer who is working on that particular piece of data. So pre-processing is a vital step of how the model can perform, or how the model is performing. So when you see the output results, you shouldn't be fed up for doing it, right? So that is something really important that you guys to understand on how important that it is to pre-process data. Okay, usually we see the results. So you'll have a confusion matrix at the end. So this is the matrix that we are seeing right now. So this is a threshold that we have. So let's say if the model is uh, we say that it is 0.85 or 85 percentage, it can tell that this is something it can do. So we do also have few of the metrics over here. I'll just expand. I think these are the few of the runs that it has done already. We don't have to plug it out. So this is the best, or which is the best accurate stuff. So 85. I don't think we do see anything. I think we can short it. So 0.85 is the max that it could go. So we do also have other metrics. So how negative it can predict. So apart from how positive it can go, you can increase the threshold. It definitely helps out on how far you can tell that, how far or how extent that you want to go. So if you want only the uh, negative part, or if you want to tell that exact model, so nobody is going to give you the. So if you keep 100, nobody or the model can never be 100 percentage, and it won't be. So if we said that, whichever is higher than 100, or if it is 100, then nothing comes out. So we just have 97. You could see few of the fields populating, 200 201 records, cross, the model tells us that it has 201 records that it can say it is predicting with 97 percentage accuracy. So that is something that you can play around with. You can see how much the model is right. For above 90 percentage, how much, so only 592 it can predict in the right pass. And again, this is also right, so you don't have to confuse with -1 and -1. So this is actually what we need, and what the model is giving us. So 12K and 592. So if we keep on decreasing it, the numbers might vary. So you can also have a different metrics. You can develop different metrics on how you can view the data in the first place. So this is the different runs that it has done already. We did run an experiment of this sort. We did start running an experiment of this sort. We didn't give the model that this is something you can do, or this is something that you can't do. So we started it, and it kind of ran how many? So it has run 10 iterations, or I would call 10 I would call that word. I don't want to bug you with all the technical stuff. It is called epochs. It could be hard to understand, but So it is kind of a iteration, so you kind of iterate along multiple times so that you could understand. So it is like memorizing stuff. If you want to memorize stuff, you kind of keep on saying that to yourself. You might have done in the younger ages that that is something you can do it to memorize stuff faster. So it is pretty much the same for a machine learning model. So it kind of iterates itself, just keeps on looking at the data. It could be with different pre-processing sets. You can also do that, or else you can keep increasing. So there is another part you have to see. I don't think we do have that graph. So for what type of iteration, what is the accuracy? So let's say I have 10K records, and the first 1K is done. So for 1K of records, half the model is predicting. So for 2K of records, half the model is predicting. So that is called epochs that you can configure. You can have 40 epochs, 50 epochs, whatever the number that you want. And based on the batch size, I'm not sure on the exact word for that, but there's a word which kind of it is a syntax, obviously. So you don't have to exactly remember that, but it is a batch size where I'm not sure if even that is a batch size. But let's say for 500 batches, like 500 times you are giving, or 500 records that you are giving, and you're running 100 epochs, and how much the model is giving you in first 1K. So you have, let's say it is like a running marathon. So for how much or in how much duration you can complete 1 kilometer, for how much time you can complete 2 kilometers. So for marathon it will obviously increase, but for in our case the accuracy should also increase. So that is something you should be mindful of when you see the graph of half the model is getting trained. So as we could see, it is it has kept on increasing. I don't see the epochs and stuff, but again, we could have at least some view on how it is happening. So you could consider this as a book. I think it is 100, if you can just imagine of that sort. Uh, for this to this extent, for 0 to 1 kilometers, uh, he or she has taken 2 minutes. So you can just consider that. So it has to keep on increasing. There could be places where it won't increase, since the model is mature enough, or it is at the saturation point. So there are two problems could occur where it can fit exactly with the data set that you give. It is called overfitting and underfitting. So underfitting is where it doesn't give you the exact output. It doesn't give you the accuracy that you need. For overfitting, it kind of gives you the super accurate results, but it is not accurate enough to tell that that is, if you just have a data set which tells all the positives. Let's say I have more data which is saying ones, and less data of -1. So it is obviously gonna say, or if it is obviously gonna fit ones more than -1s. So you should have a good mix of both these. Maybe 50 percentage. You can't just get 50 percentage. There are few data sets which is difficult to get 50 percentage, but obviously it should be closer. The gap of the number of people who are getting income greater than 50K should be equal to or lesser than the person who the total count of people who are getting income less than 50K. So it should definitely have a smaller range, so that you don't have a bias on the model itself unknowingly. So it is not just you are inducing, or you are introducing with a willingness, but it kind of introduces itself. Since the data is in that sort, we could understand that it is, since you are feeding in more data on the one side and not on the -1, it kind of does that. So it also comes on the uh, inclusion side, that we have seen diversity and part, or how fair it is for all the models. So that is something that you can really see once you start training. Just play around and see how you can. So all these things, it is available on the designer. You don't have to even drag and drop. If you want, you can definitely create a new designer or a new workbook, or you can also create a new drag and drop the entire pipeline you want. Create a different new pipeline, so you can also drag and drop stuff. So there are number of things that you can do. Data transformations, inputs. So whatever you want to do, you can definitely do load data from web URLs or various parts of cloud storage. You have a number of options where you can load data. So it is not like Kaggle notebooks. You can use the URL for it, or if you have it on blob storage, that is something that you can use. SQL database is something easier to use, but again, it is you just use this component, just click on it, it kind of sits in. So you just need to collect which data source you want, and whatever data source that you get in the drop down, which workspace that you want, file, blob, just select it and just play around and see what you can do. So make sure you stop it once you go to your compute. I think something is running, so I do have a job running as we speak. We do have something running for our designer part. I think this is the one. So make sure you stop it once you complete your whatever work that you want. You do have a stop. Since I don't have something is running, I don't get a stop option. Just don't delete stuff. Just make sure you stop. And once you want to start, maybe tomorrow, you can just click on start. So it could take some time to start and spin up, but you can definitely stop stuff and you can definitely start again once you start using it. So I think we are at seven. If you have any questions, I think we can take a couple of that, or at least one. If you have any, put it in the YouTube chat. We could definitely see. Um, okay, Kishore. So that I would. Okay. I'll cover that. So what you can do is there are free labs that you can do. I'm not sure on which certification that is. So it so you can't use all the features. Yeah. So you can't use the entire stuff. Not sure in which space it is. Um, or it could be on this as well. So you do have like a hands-on. I think this you can use. So there is a sandbox available for you guys to use. It is a 4 hour sandbox. This is something that I have never told anyone. Which I have told few, but I don't think I'm not sure on where to exactly find that. So there is like a sandbox that you guys can use for 4 hours for free. Uh, Not sure exactly on which part. So you don't need a subscription. You just need to click on activate. I'm not sure if they have removed that piece, but there was a sandbox which you guys can use for free for 4 hours. It is completely free for whichever part that you want to cover. I don't think even the pipelines that you have. So I'll try to see where I exactly tried it out. But I'm not sure. I haven't since I started using subscriptions. I didn't use the sandbox a lot. So, but there is an option. I have used it. So it says that you don't have. I think they have removed it. I guess. So exercise is where you can try out stuff in real time. They give out sandboxes for just 4 hours and for deploying just this, right. So if you have used GCP, there is something similar to it. So you just give out that particular lab and you can come out. So there was something similar with Azure. I'm not sure if they have removed it. Let me check on this one. I'll try to post the link if I get it on tomorrow's live at 6. So we'll try to see that space. If you have any other questions, I can answer that. Just hold on to this for until I just get the exact link on how to do it. But I don't like really exactly remember. But it was somewhere when I just went through the docs, I did see that. I think it was way back last year. Since they have a ton of changes that have come in, so yeah, it could have gone, but I'm not sure why did they kind of took it away. Kind of really helps for people who don't have a subscription, but again, subscription is easier to get if you have your college account. That could help. If you're a student, Azure for Students is there. You can just use your college email ID, which has to end with edu or any other domain. which is affiliated with Microsoft again. So it is not just any ID would work. That college or that university should have some kind of agreement or some kind of backend to Azure or Microsoft. So that is how that piece works. Okay. If you don't have any questions, I think we are good to go. We'll catch you tomorrow again, the same time. So I think you can also join the Discord part if you have any questions further. If you have when you practice labs, if you have any questions, you can put it on the Discord. I think the link to that and the chat you can see. It is also on the screen. We do also have shared the previous session link. So if you haven't watched that, try to kind of watch that as well. It can be helpful. If you can post some questions so that others could also learn. If you have similar questions, more people would have similar questions when deploying a model for the first time. So it could be beneficial for all the people who are just joining the community. So it kind of really helps out everyone. If you have a question, don't personally ping. You can put it on the uh, you know chat channel, so you can also help out others. We could answer that so that everybody could see that space what is happening. Okay, feedback link, I'm not sure on the feedback link. We did share it on yesterday, I guess. So that was just to see. I think we'll share it tomorrow as well, since it is tomorrow is the last day, and on the final day we do have a quiz for you guys. You could win the free certification vouchers for AI 900 and also some swags.
I think there are no more doubts, sir. Someone is asking, yeah, this Sibi wanted to ask, do we get certificate for this boot camp? So yeah, answer is yes. You all guys are going to get the certificate for this boot camp, but the certificate may take some time as it will be sent to all of you in some in batches. So I'll suggest you to be please be patient. I have pasted our Azure Developer Community Discord server link in the chat section. You must be able to see it on the screen as well. I'll strongly suggest you guys to please join this Discord server to ask for any kind of community support, any kind of resources, anything you want, and you guys can also go there every Friday. And after this boot camp, also we are going to conduct the quizzes, so you guys can go there, participate in the quizzes, enhance your learning, and as well as you guys can win the swags. And one person was asking that is there a chance to practice the stuff on Azure, just like free labs. So you don't need to worry about that if you are able to get the Azure passes. On the quiz, we gave 20 lucky winners. Like last week, they got $100 Azure passes. So you guys can go there and then you are free for any kind of stuff you want to do on Azure to learn. And gaming, Sanjeev, is there any feedback link for the session? It was shared yesterday. Today we don't have any kind of feedback links. We'll share the feedback link tomorrow to you, and we'll also send you the feedback links on your mail ID so you can fill at that time also. And I like to say thank you very much, sir, for coming here and taking out your time for such a nice boot camp. I have never seen this kind of explanation on machine learning and Azure topics. So you explain each and every topic so briefly that even a rookie who don't know anything about machine learning can get started with the things. So thank you very much for taking out your time and delivering such an insightful session. And I'll request all the audience that you guys can connect with Sir on LinkedIn as well. If you have any kind of queries after the sessions, he will be more than happy to help you. And guys, thank you for being such a lovely audience. See you tomorrow for the last day. You guys can revise these topics as well as we are having a quiz on our fourth day. So I hope you all prepare well and win goodies and all that stuff we have planned for you. And stay tuned for further sessions. Thank you, everyone. Good night.